Hello everyone. Later we discuss about today density based density and grid based methods, probabilistic and generative methods, feature selection method, and the what is clustering. Here we are going to see about distance based method. Here distance based algorithms means what? Many special forms of generative algorithms can be shown to reduce the distance-based algorithms. This is because the mixed components in generative models often use a distance function within the probability distribution. For example, the Gaussian distribution represents data generation for probabilities in terms of the equivalent distance from the mean of the mixture. As a result, a generative model with the Gaussian distribution can be shown to have a very close relationship with the k-means algorithm. I already said that k-means algorithm, um, hierarchical and DBCAN all comes under this. Sorry, it's a DBCAN all comes under density and grid-based algorithm. K-means, in fact, many distance-based algorithms can be shown into the reduction from a simplification of different kinds of generative models. Distance-based methods are often desirable because of their simplicity and ease of implementation in a wide variety of scenarios. Distance-based algorithms can be generally divided into two types. What are the two types? Flat. In this case, the data is divided into several clusters in one shot, typically with the use of Partianing representatives. The size of the Partianing representative and distance function is crucial and regulates the behavior of the underlying algorithm. In each iteration, the data points are assigned to their closest Partianing representative, and then the representative is adjusted according to the data points assigned to the cluster. It is instructive to compare with the iterative nature of the EM algorithm in which soft assignments are performed in the E steps and the model parameters analogs to cluster representative are adjusted in the M step. Some common methods for creating the Partian are, are coming. Yeah. K means as follows. I already said that K means medians, medoids, hierarchical, agglomerative, or comes here. K means in this method the Partianing representative correspond to the mean of each cluster. No, note that the Partianing representative is not drawn from the original dataset, but is created as a function of underlying. It is not drawn, it is created of the underlying data from the given data. The Euclidean distance is used in order to compute distance. The k-means method is considered one of the simplest and most classical method for data clustering and is also perhaps one of the most widely used methods in practical implementation because of its simplicity. It is a very easy to use and it is used by everyone. And is usually used by everyone. K-medians. In this method, the median along each dimension instead of the mean is used to create partitioning representative. As in the case of K-means approach, the partitioning representatives are not drawn from the original dataset. The K-medians approach is more stable to noise and outliers because of the median of a set of values is usually less sensitive to extreme values in the data. It should be noted that the term k-medians is sometimes overloaded in the literature since it is sometimes also used to refer to a k-median approach. In which the partitioning representative are drawn from the original data. In spite of this overloading and confusion, the research literature, it should be noted that the k-medians and medoids methods should be considered as distinct techniques. Therefore, in several, the medial approach discussed is really a k-medoids approach, though we have chosen to be consistent within this specific research space which we being described. Nevertheless, it would be useful to note the overloading of this term in order to avoid confusion. K-medoids. In this method, the partitioning representative is sampled from the original data. Such techniques are particularly useful in cases where the data points to be clustered are arbitrary objects and it is often not meaningful to talk about function of these objects. For example, for a set of network or discrete sequence objects, it may not be meaningful to talk about their mean or median. In such cases, partially representatives are drawn from the data and iterative methods are used in order to improve the quality of this representative. In each iteration, one of the representatives is replaced with a representative from the current data. In order to check if the quality of the clustering improves, thus this approach can be viewed as kind of hill climbing method. This method generally requires many more iterations than k-means and k-medoids methods. However, unlike the previous two methods can be used in scenarios where it is not meaningful to talk about meanings or medians of data object. Example, structural data objects. Hierarchical. In this method, the clusters are represented hierarchically through a dendrogram at varying levels of granularity. Depending upon whether this hierarchical representation is created in top-down or bottom-up fashion, this representation may be considered either agglomerative or divisive. Here is two types, that agglomerative and divisive. First, agglomerative. Agglomerative. In this method, a bottom-up approach is used, in which we start off with the individual data points and successfully merge cluster in order to create a tree-like structure. A variety of choices are possible in terms of how these clusters may be merged, which provide different trade-offs between quality and efficiency. Some examples of these choices are single linkage, all pairs linkage, centroid linkage, and sampled linkage clustering. In single linkage clustering, the shortest distance between any pair of points in two clusters is used. In all pair linkages, the average overall pair is used. Whereas in sampled linkage, a sampling of the data points in the two clusters is used for calculating the average distance. In centroid linkage, distance between the centroids is used. Some variation of this method have the disadvantage of chaining, in which larger clusters are naturally biased towards having closer distance to other points and will therefore attract a successfully large number of points in single linkage. For divisive, single linkage clustering is particularly susceptible to the phenomenon. A number of domains such as network clustering are more susceptible to this behavior. Divisive. In this method, a top-down approach is used in order to successively partition the data points into a tree-like structure. Any flat clustering algorithm can be used in order to perform the partitioning at each step. Divisive partitioning allows greater flexibility in terms of both the hierarchical structure of the tree and level of balance in the different clusters. It is not necessary to have a perfectly balanced tree in terms of the depths of different nodes or a tree in which the degree of every branch is exactly 2. This allows the construction of a tree structure which allows different trade-offs in the balancing of the node depths and node weights. For example, in a top-down method, if the different branches of the tree are unbalanced in terms of node weights, then the largest cluster can be chosen preferentially for division at each level. Such an approach is used to METIS in order to create well-balanced cluster in large distance networks in which the problem of Cluster imbalance is particularly severe while METS is not distance-based algorithms is generally principle applied to it's a general principle applied to distance-based algorithms. Distance-based algorithms are very popular in the literature because they can be used with almost any data type as long as appropriate distance function is created for the data type. Thus, the problem of clustering can be reduced to a problem of finding a distance function for the data type. Therefore, distance function design it has itself become an important area of research for data mining on its own right. Dedicated methods also have often been designed for specific data domains such as categorical or time series data. Of course, in many domains such as high dimensional data, the quality of the distance function reduces because of many irrelevant dimensions and many so both errors and concentration effects, which reduce the statistical significance of data mining results. In such cases, one may use either the redundancy in larger portion of the pairwise decision matrix to subtract out the noise in the distance competition with the spectral methods or projection in order to directly find the clusters in irrelevant subsets of attributes. Density we already see in the earlier video. Okay, thank you.